The Kamchatka eruption has ignited a wave of concern among volcanologists, seismologists, and disaster preparedness agencies worldwide. In the United States, the conversation has taken a sharp turn toward the question no one wants to say out loud, but everyone is thinking: could an event like this set the stage for Yellowstone, or another supervolcano on American soil, to stir from its slumber? Dr. Emily Carter, a geophysicist with the US Geological Survey, didn't mince words in a recent interview. While volcanic systems are incredibly complex and each one operates on its own geologic timetable, major eruptions anywhere on Earth remind us of the interconnectedness of the planet's tectonic magmatic systems, she said. No, we're not saying Yellowstone is about to erupt tomorrow, but global-scale geologic activity can sometimes coincide with shifts in other regions. Her comments have been seized upon by both the scientific community and a nervous public eager to understand what coincide might mean in practical terms. Yellowstone has long been the poster child for America's supervolcano anxiety. Its massive caldera, formed by past cataclysmic eruptions, sits atop a deep mantle plume feeding a vast magma reservoir. Past events, the last of which occurred about 640,000 years ago, blanketed much of the continent in ash and triggered long-lasting climate effects. Modern monitoring shows regular seismic swarms, ground uplift, and shifting hydrothermal activity. While these phenomena are normal for an active volcanic system, the recent surge in global seismic energy has some scientists quietly re-evaluating risk probabilities. Dr. Jonathan Myers, a volcanologist at the University of Utah, noted the Kamchatka eruption was large enough to inject significant ash into the stratosphere, and it registered strongly on our seismic networks. While that doesn't mean Yellowstone is being triggered, it's part of a larger picture where we have to ask if the planet is entering a phase of heightened volcanic activity. His emphasis on larger picture has sparked debate, particularly in online forums where doomsday scenarios tend to eclipse measured analysis. Beyond Yellowstone, experts are turning their eyes to the Long Valley Caldera in eastern California, a less famous but geologically potent volcanic system. Roughly the same age and scale as Yellowstone, Long Valley has experienced episodes of unrest, including significant seismic swarms in the late 20th century and ongoing ground deformation. Unlike Yellowstone, it lies close to major population centers and critical infrastructure corridors. A large-scale eruption there could disrupt transportation, agriculture, and air traffic across much of the western US. Long Valley doesn't get the same attention, but it has the potential to produce massive explosive eruptions, explained Dr. Sarah Kim, a hazard modeling specialist at Caltech. We keep a close eye on it for the same reasons we watch Yellowstone, because when these systems do erupt, they can alter climate and society on a global scale. Then there's Alaska, home to the Aleutian volcanic arc, a chain of volcanoes stretching across a tectonic boundary where the Pacific plate dives beneath the North American plate. While most of these volcanoes are not supervolcanoes in the Yellowstone sense, their combined activity has enormous potential for disruption. Alaska's volcanoes sit directly under some of the busiest air routes between North America and Asia. Ash clouds from even moderate eruptions can force the diversion of hundreds of flights, causing global ripple effects in commerce and logistics. Dr. Michael Ortiz, a senior analyst at the Alaska Volcano Observatory, drew a direct line from Kamchatka's eruption to Alaska's watch lists. The Pacific Ring of Fire is one connected system in terms of tectonic forces, he said. While a big blast in Kamchatka doesn't cause an Alaskan volcano to erupt, both are being driven by the same large-scale geodynamic processes. It's not unreasonable to see one active arc and ask whether others are poised to follow. The question lurking beneath all these expert statements is both simple and unsettling. Is nature waking up? That phrase has become a rallying point for media headlines and social media speculation. On one level, it's a human way of framing what may simply be normal fluctuations in geologic activity. On another, it reflects a deep unease that humanity's window of geological stability could be narrowing. In geological time, quiet periods are temporary. The Earth's crust is always in motion, its molten interior always seeking release. History shows that clusters of major eruptions can occur within centuries or even decades of one another, particularly in tectonically active eras. Whether the Kamchatka eruption marks the start of such a phase is a question science can't answer with certainty, but one it can monitor with ever-increasing precision. In the United States, that monitoring effort is more sophisticated than ever. Yellowstone's seismic network includes dozens of high-sensitivity seismometers, GPS stations measuring ground deformation to millimeter precision, and continuous gas sampling and thermal features. Long Valley has a similar, though smaller, array. In Alaska, volcanoes are tracked by a combination of seismology, satellite thermal imaging, and in some cases infrasound sensors that can detect explosions across thousands of kilometers. These systems feed real-time data into national and international databases, allowing researchers to spot anomalies quickly. But even the best monitoring can only provide early warnings, not predictions years in advance. We can often tell you when a volcano is entering a heightened state of unrest, Dr. Carter said, but we can't yet give you a long-term schedule of when it will erupt. That's just not how these systems work. The Kamchatka blast has already prompted quiet policy discussions about updating emergency preparedness plans for volcanic hazards in the US. The Federal Emergency Management Agency, FEMA, the US Geological Survey, and several state-level agencies are reportedly reviewing evacuation protocols, ashfall mitigation strategies, and public communication frameworks. In Alaska, where volcanic activity is frequent, these measures are routine. In Yellowstone's surrounding states, Wyoming, Montana, and Idaho, they are far more hypothetical, but the stakes are exponentially higher. An explosive eruption at Yellowstone could affect not just the US, but global agriculture, climate, and economic systems. Long Valley, while smaller, could still devastate the western US and beyond. Preparation is not about fear, Dr. Kim emphasized. It's about resilience. The Kamchatka eruption is a reminder that the Earth doesn't operate on our schedules, and being ready is the only rational response. Still, the public conversation tends to swing between two extremes: complacency and alarmism. On one side, people point to the long recurrence intervals of supervolcano eruptions as evidence that nothing is imminent. On the other, some interpret every tremor or hydrothermal change as an early warning sign of catastrophe. Scientists, for their part, stress the importance of staying grounded in data while acknowledging that uncertainty is part of the equation. Nature doesn't give us guarantees, Dr. Myers said. It gives us patterns, probabilities, and signals. The challenge is interpreting those without letting fear or wishful thinking distort the picture. That balance between vigilance and panic is likely to define the discourse for months to come, especially if other volcanoes around the world begin to show signs of awakening. For now, Yellowstone remains calm in the ways that matter most: seismicity within historical norms, ground uplift within expected seasonal ranges, gas emissions steady. Long Valley is stable. Alaska's volcanoes are active, but not unusually so. And yet, the shadow of Kamchatka lingers. Every plume of steam in Wyoming, every quake in California, every rumble in the Aleutians is now being viewed through a new lens, one tinted by the memory of ash clouds billowing over the Russian Far East. Whether that vigilance fades or sharpens will depend on what nature decides to do next. In the meantime, scientists continue their watch. Instruments hum quietly in the background, and the unspoken question, could Yellowstone be next, hangs in the air, unanswered but impossible to ignore. The eruption in Kamchatka has left both scientists and the public wrestling with a rare combination of awe and unease. Its sheer scale, captured in satellite images and seismograph spikes, was a visceral reminder that Earth's most powerful forces operate on a timeline far beyond human control. For many Americans, the next thought was immediate. If such an event can happen there, what about here? The United States, after all, is home to some of the most formidable volcanic systems on the planet. The question, whether posed in a measured scientific tone or as a breathless headline, has taken center stage. Could the energy released in Kamchatka, in some interconnected way, influence Yellowstone or other massive volcanic complexes? Scientists are careful to say that a direct trigger across continents is extremely unlikely. The mechanics of magma movement, crustal stress, and tectonic interaction are complex, and distance matters. Yet, history does record periods when multiple large eruptions occurred within a relatively short geological window, suggesting that global tectonic conditions can sometimes align in ways that elevate activity in multiple locations. Dr. Laura Hendricks, a volcanologist with decades of experience in monitoring caldera systems, put it this way. Think of the Earth as one great engine with many moving parts. A significant event in one part of the system doesn't pull a lever that sets off another, but it might be a sign that the engine itself is in a different gear. Yellowstone, with its immense underground magma reservoir and history of colossal eruptions, remains the primary focus of this line of thinking. Its last major eruption, hundreds of thousands of years ago, left a caldera nearly 45 miles wide. Today, the park's geothermal features, the geysers, hot springs, and fumaroles, are surface expressions of the heat still simmering below. Satellite data shows that parts of the park rise and fall subtly over the years, as though the ground itself were breathing. Normally, this is part of the natural rhythm of a living volcanic system. But in the wake of Kamchatka, each microquake and each unusual thermal reading is scrutinized more closely. Not because scientists expect an immediate eruption, but because vigilance is the cornerstone of readiness. Long Valley Caldera, farther south in California, presents a quieter but no less serious profile. Nestled east of the Sierra Nevada, it is a reminder that supervolcanoes don't always roar to life. They can whisper for decades before acting. In the late 1970s and early 1980s, a sudden burst of seismic activity there raised alarms. And even though no eruption followed, the event led to the installation of comprehensive monitoring systems. Dr. Alan Reyes, a seismic hazard expert, warns that the attention given to Yellowstone should not eclipse Long Valley's potential. It's the volcano you don't think about that can surprise you, he said. If a large-scale eruption occurred there, the impact would ripple across transportation, air quality, agriculture, and the economy in ways most people don't imagine. Alaska's volcanic chain is of a different nature. More numerous eruptions, but generally on a smaller scale than supervolcanoes. The Aleutian Arc's volcanoes erupt with enough frequency that many communities in the region treat volcanic ash advisories almost like weather reports. Yet, their position under trans-Pacific flight corridors means even a mid-sized eruption can have consequences far beyond Alaska. Air traffic diversions, shipping delays, and potential climate effects from high-altitude ash all make the region's activity a matter of global concern. The connection to Kamchatka here is more than symbolic. The two arcs are part of the same tectonic boundary, a geologic seam where immense forces meet. When one segment is active, it's reasonable for scientists to pay heightened attention to its neighbors. The larger question, whether nature is waking up, isn't one science can answer in absolute terms. Geological wakefulness is measured in thousands or millions of years, and humans live in a blink of that time. Still, the clustering of notable eruptions in the 21st century has made even sober analysts more alert to potential patterns. Advances in remote sensing, machine learning applied to seismic data, and gas composition analysis mean we are better equipped than ever to detect early signs of unrest. But this capability also means we see more anomalies, and interpreting them without falling into alarmism requires discipline. Public perception, however, doesn't operate with that discipline by default. The viral nature of news and social media ensures that speculation outpaces confirmed data. A drone video of ash clouds over Kamchatka can be on millions of screens within hours, accompanied by captions linking it to Yellowstone or other US volcanoes, whether the science supports that link or not. This creates a feedback loop where fear becomes part of the narrative, making the work of scientists both more urgent and more difficult. They must communicate not only the raw data but also its meaning, navigating the thin line between raising awareness and stoking panic. In response to the heightened interest, US agencies have subtly increased their outreach. The Yellowstone Volcano Observatory has updated its public FAQs. The Alaska Volcano Observatory has issued explainers about how Kamchatka's activity is monitored from afar. And even regional emergency management offices in California have fielded more questions about Long Valley in the past month than in the previous year. This surge in public curiosity can be a double-edged sword. On one hand, it fosters a population that is more aware of natural hazards. On the other, it risks overloading the discourse with conjecture. For now, the consensus among experts is that Yellowstone, Long Valley, and Alaska's major volcanoes remain in their normal states of activity. There is no evidence that the Kamchatka eruption has altered their internal dynamics. Yet the psychological shift it triggered is undeniable. Americans are looking more closely at their own geologic backyard, and scientists are recalibrating their watch with the knowledge that Earth's most powerful systems are always in motion. The question that lingers, whether these observations herald a new era of heightened volcanic activity, remains unanswered, but it will continue to shape how we think, prepare, and live under the vast, unpredictable sky. When the ash from Kamchatka drifted across the upper atmosphere, spreading its veil thousands of miles from the eruption site, it carried more than microscopic volcanic glass. It carried a renewed sense of fragility. In the United States, that feeling is magnified by the knowledge that some of the world's most potentially destructive volcanic systems lie within its borders. Yellowstone is the name on most lips, but in the background, Long Valley and Alaska's vast volcanic arc remain equally watched. The parallels are unsettling. Kamchatka's eruption was sudden, immense, and unmistakable, proof that in the realm of geology, silence is never permanent. Experts are now sifting through seismic data, satellite imagery, and gas emission readings, not because they expect an immediate US eruption, but because events of this magnitude force a reassessment of risk, however remote it might be in the short term. Dr. Rebecca Sloan, a senior geologist at the US Geological Survey, explained the delicate position of the scientific community. People want certainty, but with volcanoes, certainty is not part of the equation. We deal in probabilities, in patterns, in subtle shifts over time. The Kamchatka eruption didn't wake up Yellowstone, but it does remind us to keep our eyes open. Her words reflect a balance between calming the public and encouraging vigilance, a balance made more difficult by the sheer drama of volcanic imagery and the way it fuels the human imagination. Social media posts, with their side-by-side comparisons of Kamchatka's plume and Yellowstone's caldera, spread quickly, often skipping over the nuance in favor of impact. Yellowstone's underground system is, for now, behaving as expected. Minor earthquakes within the historical range, predictable seasonal ground deformation, and stable hydrothermal activity. Yet every tremor is logged, every change in geyser behavior noted. The Yellowstone Volcano Observatory maintains a round-the-clock watch, its instruments streaming real-time data to analysts who can detect even the smallest deviation from baseline. This level of scrutiny is part of what reassures scientists. Patterns are known, thresholds are clear. Still, in a post-Kamchatka context, those same patterns are read with just a bit more intensity. Long Valley Caldera's situation is similar, but more understated. Located near Mammoth Lakes in California, it has a history of dramatic geological changes, uplift, swarms of quakes, and gas emissions that have at times killed vegetation in certain areas. While these events have not led to an eruption in modern history, they serve as reminders that the system is alive. Dr. Miguel Hernandez, a California-based hazard modeler, sees Long Valley as a wild card. "We get used to thinking of danger as coming from the most famous source," he said, "but geology doesn't respect brand recognition. Long Valley's potential is on par with Yellowstone in certain scenarios, and its proximity to dense populations and vital infrastructure makes it a different kind of risk." Alaska's volcanic arc, with more than 40 active volcanoes, exists in a state of near constant low-level activity. Pilots and air traffic controllers are used to receiving ash advisories, and eruptions that would be headline news elsewhere are in Alaska part of the background rhythm. But this normalcy is precisely why experts pay attention. Familiarity can breed complacency, and when a large event does occur, the consequences can be swift and far-reaching. The ash from an Alaskan eruption can reach flight altitudes over the Pacific in hours, forcing reroutes that ripple through global logistics. The link to Kamchatka is not in direct cause and effect, but in tectonic kinship. They share the same Pacific Ring of Fire, driven by similar forces deep beneath the crust. The concept of nature waking up is more poetic than scientific, but it resonates for a reason. In geological history, there have been periods of intensified volcanic activity across multiple regions, suggesting that the planet's deep processes can shift into more active phases. Whether we are entering such a phase is unknown, but Kamchatka's eruption has reminded everyone that the conditions for massive change are always present, waiting. The question is not if Earth will act, but when and where. This awareness is shaping policy discussions behind closed doors. Emergency management agencies are reviewing protocols, scientists are refining hazard maps, and communications specialists are drafting public messaging that balances preparedness with realism. The aim is not to spark panic, but to ensure that if unrest does arise, whether in Yellowstone, Long Valley, or Alaska, the response will be coordinated, informed, and swift. The lessons from Kamchatka are not just geological, they are logistical and social. A large eruption is as much a societal test as it is a natural event. For now, the instruments hum quietly, the data flows steadily, and America's supervolcanoes remain in their current states, alive but not agitated. Yet the memory of Kamchatka's sudden fury lingers, and with it, a sharpened sense of respect for the forces beneath our feet. Whether this is the prelude to a more active era, or simply another chapter in Earth's restless history, one thing is certain. The watch continues, and the question, could Yellowstone be next, remains suspended in the air, as persistent as the ash still drifting high above the Pacific. The Kamchatka eruption has, in many ways, become a global case study in how quickly a dormant fear can return to the surface. For years, Yellowstone, Long Valley, and Alaska's volcanoes have been quietly monitored, their datasets growing into an ever more detailed picture of subterranean life. But when a massive blast tears open the ground in one part of the Pacific Ring of Fire, it is impossible not to look elsewhere and wonder what lies ahead. In public discussions, the phrase domino effect has been thrown around, though experts are quick to point out that volcanoes do not trigger each other in such a simple way. Still, they acknowledge that the same tectonic forces driving Kamchatka's eruption are part of a global system, one in which multiple regions can experience heightened activity over relatively short geological periods. Yellowstone remains the most famous and feared of America's volcanic giants. Beneath its forests and hot springs lies a massive magma chamber, fed by a plume of molten rock rising from deep within the Earth. In the public imagination, an eruption there is a singular apocalypse, the kind of event that blots out the sun and alters the course of civilization. The reality is more nuanced. Most volcanic activity at Yellowstone is limited to hydrothermal explosions, small lava flows, or regional ashfall, none of which are extinction-level events. Yet the presence of a supervolcano means that, however remote the probability, the worst-case scenario must be taken seriously. Dr. Nathan Cole, a senior volcanologist, explains, "A Yellowstone eruption tomorrow is extremely unlikely, but the Kamchatka event is a stark reminder that large eruptions do happen, and that our job is to be ready, not to guess dates, but to respond effectively if warning signs appear." Long Valley Caldera in California's eastern Sierra Nevada has its own story of near misses and ongoing unrest. In the early 1980s, a swarm of earthquakes and rapid ground uplift alarmed scientists enough to issue advisories to nearby communities. Those changes eventually subsided, but the monitoring systems installed during that period remain active today, feeding real-time seismic and deformation data into national databases. Its proximity to Los Angeles and San Francisco's transportation corridors means that an eruption, even one far smaller than Yellowstone's potential, could have devastating consequences. Dr. Cole warns that Long Valley's hazards are often underestimated because the region looks so ordinary from the surface. It's easy to think danger comes from mountains with smoke at the top, but some of the most dangerous volcanic systems are quiet until they're not. Alaska's Aleutian arc is an entirely different kind of hazard, less about singular cataclysm, more about frequency and logistical disruption. Dozens of active volcanoes dot the chain, many erupting every few years. These eruptions may not darken the skies for weeks, but they can inject ash into altitudes used by trans-Pacific flights, forcing reroutes and creating economic chain reactions. The link to Kamchatka is geographical as much as geological. Both sit along subduction zones where the Pacific plate dives beneath continental crust, feeding magma systems with a steady supply of molten rock. While a major Kamchatka event does not mechanically set off an Alaskan eruption, scientists know that shared tectonic conditions can mean similar stress changes in the crust. The phrase, "Is nature waking up?" has moved from speculative headlines into everyday conversation. While scientists hesitate to frame volcanic activity in such anthropomorphic terms, they acknowledge that clusters of major eruptions have occurred in the past, often separated by centuries or millennia of relative quiet. Dr. Emily Carter from the USGS puts it bluntly, "Earth doesn't wake up, it's always awake. We just notice certain moments more, especially when they happen in dramatic fashion." That distinction is crucial. What feels like a sudden change is often the visible peak of a process that has been building quietly for decades or centuries. In the wake of Kamchatka, US monitoring agencies have been running simulations of potential eruption scenarios, reviewing evacuation routes, and updating public communication strategies. FEMA's volcanic hazard planners have quietly met with regional officials in Wyoming, Montana, Idaho, California, and Alaska to review what resources could be mobilized in an emergency. These are not panic meetings, they are continuity exercises, the kind of behind-the-scenes work that rarely makes headlines, but can save lives. Yet, the challenge remains, communicating the seriousness of preparation without fueling unnecessary fear. If the public tunes out, they miss critical updates when they matter most. If they panic, the response infrastructure can be overwhelmed before the real crisis even begins. Striking that balance is as much an art as it is a science. As Dr. Carter notes, our job is to keep people informed, not frightened. But ignoring the lessons of Kamchatka would be just as dangerous as overreacting to them. For now, the watch continues, calm but focused. Yellowstone steams quietly in the winter air, Long Valley lies under a blanket of high desert snow, and Alaska's volcanoes send up their occasional plumes into the cold northern sky. Beneath them all, magma moves in ways we can measure but never fully control. And as long as that is true, the question, whether nature is preparing something larger, will remain, a shadow in the background of every plume of smoke, every tremor, every distant eruption. In the aftermath of Kamchatka's eruption, the images of towering ash clouds and rivers of molten rock have already become a kind of modern cautionary tale, a reminder that Earth's forces are as unyielding as they are unpredictable. In the United States, where Yellowstone, Long Valley, and Alaska's volcanoes quietly persist, the event has rekindled an uncomfortable truth. These systems are not relics of the past, but living parts of a planet in constant motion. The scientific consensus remains that Kamchatka's eruption did not directly destabilize these American giants, but it has shifted the tone of the conversation from abstract hazard to present-day possibility. That shift matters. It shapes how scientists frame their briefings, how agencies plan for contingencies, and how the public perceives the urgency, or lack thereof, of preparedness. Yellowstone's geothermal heart beats slowly but steadily. With its cycles of uplift and subsidence, its occasional swarms of microquakes, and the endless dance of steam and boiling water through its hydrothermal features. To those who study it daily, these are the normal rhythms of a vast but stable system. Yet in the context of Kamchatka, every seismic blip becomes a headline, every geyser delay a question mark. Dr. Rachel Nguyen, a geophysicist with years of experience at the Yellowstone Volcano Observatory, points out that the challenge now is less about detecting change and more about interpreting it for a public on edge. Our instruments are sensitive enough to pick up minute shifts in pressure and movement deep underground, she explains. The real work is translating that into language that is accurate, clear, and won't be misconstrued as an imminent threat when it isn't. Long Valley Caldera shares that same communication challenge, though its profile is less familiar to most Americans. When minor unrest occurs there, a few tremors, subtle ground deformation, it tends to stay out of the national spotlight. But scientists know better than to ignore it. The system has a history of large explosive eruptions, and even a moderate event could cripple infrastructure across the western US. Dr. Anthony Wells, a hazard assessment coordinator in California, describes Long Valley as a quiet neighbor who keeps to themselves until one day you hear something in the basement and realize you've been living next to a loaded cannon the whole time. It's a vivid analogy, one that underscores why constant monitoring is non-negotiable. Alaska's volcanic arc, meanwhile, hums along in its own pattern of frequent but mostly moderate eruptions. These volcanoes are less likely to produce the planetary scale effects of a Yellowstone or Long Valley blast, but they hold a different kind of power, the power to disrupt global systems in a matter of hours. Ash plumes in the wrong airspace can force the diversion of hundreds of flights, grounding tens of thousands of passengers and rerouting cargo shipments worth billions. The Kamchatka eruption, occurring along a similar tectonic margin, has reinforced the importance of monitoring not just for hazard mitigation in Alaska itself, but for the stability of trans-Pacific commerce. The notion that nature is waking up persists, fueled by media repetition and the human instinct to find patterns in events. While scientists resist the metaphor, they acknowledge its emotional pull. There is a kind of primal unease in watching a distant eruption and knowing that similar forces exist beneath your own country's soil. History tells us that volcanic activity does ebb and flow over time, sometimes clustering in ways that defy easy explanation. Whether Kamchatka marks the start of such a cluster or stands alone as a singular event is something only time will reveal. Behind the scenes, agencies are already moving. FEMA, USGS, and state emergency planners are updating hazard scenarios, rechecking evacuation route feasibility, and refining their chains of communication. In Wyoming, Montana, and Idaho, the states most immediately affected by a Yellowstone eruption, local officials are quietly assessing supply stockpiles and shelter capacities. In California, Long Valley's maps and contingency plans are under review. Alaska continues its routine readiness drills, aware that its next eruption could arrive with only hours of warning. These are not reactions born of panic, but of pragmatism, accepting that the only way to be unshaken by Earth's surprises is to prepare before they arrive. Yet, no matter how meticulous the preparation, uncertainty will always be part of the equation. Volcanoes do not work on human timelines, and their signs can be ambiguous, prolonged, or misleading. A sudden swarm of quakes might lead to nothing. A period of quiet might mask changes occurring deep below. This is the paradox of volcanic monitoring. The more we know, the more we realize how much remains hidden. For scientists, this is motivation. For the public, it can be a source of unease. And in the post-Kamchatka moment, that unease is more palpable than it has been in years. For now, Yellowstone steams quietly, Long Valley rests beneath its winter sun, and Alaska's volcanoes breathe plumes into the cold air without fanfare. But the awareness has changed. The next tremor, the next puff of ash, will be seen not just as a local event, but as part of a global story. A story in which the question, could Yellowstone be next, no longer feels like a hypothetical for a far-off future, but a living question woven into the present. The Kamchatka eruption has done more than send ash across continents. It has unsettled the psychological balance between scientific caution and public perception. In the scientific community, the consensus is clear. Yellowstone, Long Valley, and Alaska's volcanic systems remain within normal parameters. Yet normal in volcanology is a nuanced concept, one that includes constant seismic tremors, measurable ground movement, and fluctuating hydrothermal activity. These are not signs of imminent catastrophe, but they are signs of life. And when the world has just witnessed a colossal eruption, life beneath the surface suddenly feels closer, louder, more relevant. The question, could Yellowstone be next, is no longer confined to late-night disaster documentaries. It is being asked in classrooms, at dinner tables, and in quiet conversations in communities that sit within reach of volcanic hazard zones. Yellowstone's watchers, the scientists, technicians, and analysts at the Yellowstone Volcano Observatory, are acutely aware of this shift. Their work has always been a balancing act between vigilance and reassurance. Each GPS reading, each seismic trace, each gas emission sample is weighed against decades of baseline data. When changes occur, they are measured not in terms of panic, but in terms of probability. The most dangerous thing we can do is either ignore the data or overreact to it, says Dr. Michael Anders, one of the observatory's senior geophysicists. The Kamchatka eruption was dramatic, but our job is to interpret Yellowstone's signals in Yellowstone's context, not in the shadow of another volcano's event. His words highlight the challenge. the public tends to view volcanic risk as contagious, as though one eruption might spark another half a world away. In reality, the connection is more subtle, a matter of shared tectonic forces, not direct cause and effect. Long Valley Caldera, despite being one of the most dangerous volcanic systems in the continental US, lives in relative obscurity compared to Yellowstone. That obscurity can be both a blessing and a risk. The scientific teams monitoring it are no less rigorous, but the public's awareness is lower, meaning preparedness campaigns must work harder to gain traction. Situated near key transport corridors, an eruption there, even on a modest scale, could have cascading effects on travel, commerce, and air quality. In this moment of heightened volcanic attention, some scientists hope the Kamchatka coverage will spur renewed interest in Long Valley's hazard profile. It's not about making people fearful, says Dr. Elena Hart, a volcanologist at Caltech. It's about making them aware that being inland doesn't make you immune to volcanic disruption. Alaska's Aleutian arc, with its frequent smaller eruptions, offers a different lesson in hazard management. There, volcanic activity is a constant backdrop, and the systems for tracking, warning, and adapting are well practiced. Air traffic over the North Pacific depends on the accuracy of Alaska's monitoring networks, and pilots rely on those alerts to navigate around ash clouds that can disable engines in minutes. Kamchatka's eruption underscored how swiftly such disruptions can ripple through global air travel. The Pacific Ring of Fire is vast, but its components share enough geological kinship that activity in one region often prompts closer scrutiny of others, if only as a precaution. The idea of nature waking up carries undeniable emotional weight. It frames Earth's processes in human terms, making them feel intentional, even sentient. Scientists resist the metaphor, yet they also recognize its usefulness in engaging the public. Historically, periods of heightened volcanic activity have occurred in clusters, separated by long intervals of relative calm. Whether Kamchatka marks the start of such a phase is unknowable in the short term, but the increased attention is prompting tangible action. Emergency plans are being revisited, hazard maps are being updated, response drills are being fine-tuned. This is preparation in its most practical form. Quiet, systematic, and grounded in the understanding that the best time to plan for a disaster is before the first clear warning sign appears. Still, even the most detailed monitoring cannot remove the inherent unpredictability of volcanic systems. The signs that precede a major eruption, earthquakes, ground swelling, gas changes, can build over months or years, or they can surge in a matter of days. Conversely, such signs can fade without leading to an eruption at all. This ambiguity means that readiness is as much about resilience as it is about prediction. Communities near Yellowstone, Long Valley, and Alaska's volcanic zones are being encouraged to see preparedness not as an admission of imminent danger, but as a safeguard for a range of possible natural events. For now, the landscapes above these immense forces remain deceptively tranquil. Yellowstone's geysers send their predictable plumes into the air, Long Valley's ridges sit quiet under seasonal snow, and Alaska's volcanic peaks are etched against the northern sky in stillness. But beneath that stillness, the same forces that shaped Kamchatka's eruption are at work, slow, immense, and indifferent to human timelines. Whether the next chapter of this story is written years from now or within our lifetimes is a mystery no instrument can fully solve. What is certain is that the watch will not stop and the question will not fade. Could Yellowstone be next? The answer remains unwritten, somewhere deep beneath the crust, in chambers of heat and pressure that wait patiently for their moment.